Hello, everyone, and welcome to our Test Sentinel 2.0 webinar. If for those that don't know, Test Sentinel is our DSL, Gfast, and wireless testing automation software. I'd like to welcome you. My name is Danny Moss. I'm a broadband project manager here at the UNH-IOL. I'm joined by Anthony Pilot, who's our lead developer on Test Sentinel. I'd like to let everybody know that at any point you can add your questions into the Q&A box through Zoom. We'll address all of them at the end. So first, I'd like to get into a little bit who we are. So maybe you're familiar with the UNH-IOL. I'd imagine a lot of you probably are, but I'll give you a little history. Then we're going to talk about Test Sentinel and how it works. I'll pass over to Tony for that one. We're going to do a demo video for you. We have some use cases and user benefits, and then at the end there we'll do Q&A. So the UNH Interoperability Lab has been around since 1988. We're based in Durham, New Hampshire, part of the University of New Hampshire, fully funded by industry. UNH-IOL is a nonprofit, and we're a third-party laboratory. We work in 35 different technologies all over the data networking field. Particularly for DSL, we've been in the industry for since the 90s, basically since the foundation of DSL, and same with wireless as well. So a little more about our laboratory here at the lab. Our DSL stuff specifically, we've had a lab for years and years, like I said, since the late 90s. We are a long-term participant in the broadband forum since before it was the broadband forum, and it was actually the ADSL forum or DSL forum. We have a huge test bed of over 40 DSLAMs from different manufacturers. This includes all sorts of legacy stuff, back to ADSL, all the way through modern 35B equipment. We also have many different DPUs for Gfast. We are the main laboratory for the Broadband Forum Gfast certification, ID 337. The only ones able to actually issue the certification. We are heavily participating in development of that test plan and development of Gfast as a technology. We also participate in many of these other standards for test plans through the Broadband Forum, including all the TRs that you'll of TR 100, 67, 114, all of those. So we have some experience in the DSL field. So I'm going to pass this over to Tony for Test Sentinel and how it works.
All right, hello. My name is Tony, as Dan mentioned. I am the lead software developer for Test Sentinel here at the lab. And I'm an undergraduate student here at UNH as well. So I'm just going to talk a little bit about what Test Sentinel is and how it works and how it can help you out as well. And we'll follow that up by a short demo video that's going to showcase one of the newest features of Test Sentinel that I'll describe in detail as we continue here. So let's begin with how Test Sentinel started and what it's used for. Here at the IOL, we have members that are constantly requesting our testing services for DSL and Gfast. And in order to make our lives easier, back in the early 2000s, Test Sentinel was started as a small application that we would use here to automate these certain tests. So we began with some of the DSL tests such as Tier 100, Tier 114, and as Gfast came along, we implemented the ID 337 testing to be automated with this Test Sentinel software. And eventually it reached a point where we would be able to sell the software to other labs. That way, it can help you automate these tests very quickly without having to manually perform them. So as I mentioned, there's a wide variety of DSL tests. We have the Gfast testing, as well as now very recently wireless testing, in more recently Tier 398 for the wireless stuff. And it also supports some customized testing, such as custom reach versus rate testing for DSL and Gfast. And the newest feature of Test Sentinel that will include completely custom test scripting, which I'm going to talk about in detail as we continue along here. So I'm going to speak a little bit about how Test Sentinel works because it's made up of three main parts. Firstly, the actual Test Sentinel application is a Windows-based application, and this is what controls devices and as well as what automates the actual tests. So as you can see in the diagram on screen, Test Sentinel is what will control your DSLAM, all your impairments, such as noise and loop simulators, etc. Next, as a test is being automated by Test Sentinel, it's going to write all of its data to a MySQL database. So this is going to store all the test results, what passed, what failed, and why, as well as any measurements that were recorded. Finally, this data that's stored in the database can then be viewed via a web-based reporting system. This is built using PHP, and it's used to view and analyze all of the past test results. So any automated test that was run can be viewed here, exported to CSV files, and you can view all the graphs and stuff. So we're going to talk about each of these parts in more detail here. Firstly, we'll talk about the Windows-based application that performs the automation. As I mentioned, Test Sentinel is extremely powerful in managing your connection and communication with all devices. So Test Sentinel supports a very wide variety of DSLAMs and DPUs that can be all configured in the same way with Test Sentinel. So for example, if we have a DSLAM that we wish to control, we can create a DSLAM profile from within Test Sentinel, and that profile can be written once and saved, and then set to all different types of DSLAMs that Test Sentinel supports. And Test Sentinel will handle converting that profile into the proper commands based on what device you wish to set that profile to. Test Sentinel is also used for reading device information and measurements from devices, and anything that's required for the test automation. Now, in addition to automating all these DSL and Gfast tests, the software also contains a very wide range of tools that are able to be used. For instance, there's a tool that will allow you to directly control any CO device, meaning DSLAMs or DPUs. You're going to see this a little bit in the beginning of the demo video that I play, but this tool is extremely useful for debugging. So you can quickly set any profile that you have in your library to any DSLAM or DPU that you have, and pull any measurements or performance counters that you wish. The same goes for controlling other types of devices, including traffic generator control to be able to configure what traffic to run and run the traffic and then view the traffic results as they come back, as well as set up your impairment devices, loop lengths, noise settings. And it all allows you to save, load, and change all these profiles and configurations very simply through one universal and consistent application here. Now, more recently, as I mentioned, Test Sentinel has implemented completely customized testing. So this software will also allow you to configure and create these tests on your own, which we're going to cover in a lot of detail here in the video. And it works similar to a drag and drop programming language. And this will allow you to evaluate any of the test logic and metrics, either predefined by us for tests like TR114 or Gfast, or completely customized metrics that you at your lab might want to make. And all of this data is written to a MySQL database. So Test Sentinel will record any information that is pertinent to the testing to this database. That means if you're running a test, it's going to record all measurements from your DSLAM, for instance, including the line rate, SNRM, all the performance counters, as well as all of the test metrics. So if you're running a Gfast test, it will list what sections were run and whether or not a certain section passed or failed, as well as why it passed or failed. And this might record data that can be viewed with tables and graphs in the reporting system later on. And because of this wide amount of information that is recorded to the database by Test Sentinel as a test is running, this can allow you to delve much deeper into your test that is run to be able to analyze exactly what's going on and maybe what the problems are during that test or what's going really well. So this is all helping to organize, and in addition to this, it organizes all this data in a very generic and consistent way. So if you're running a DSL, Gfast, or a wireless test, all this data is stored in the same structure in the database. It can all be viewed in a very similar manner, even though they're completely different technologies. And finally, there's the reporting system. Again, this is web-based, so it can be viewed using a web browser. And this just essentially provides a really nice, clean, and consistent view into the database. So you can view any of your past automations that you have run or anything that is currently running. It will allow you to generate PDF test reports. So if I have a Gfast test that I run, I can create a very nice looking report with all of the test metrics, data, and graphs that I might want. Very helpful for analyzing results and performance of a test. And it can also allow you to create your own views, such as tables that you might want specific information to be in. So I've been mentioning that there's a very new feature of Test Sentinel, and that is called the Test Creator, which allows for completely customized test scripting. There's a few screenshots here, and the demo video will cover this quite extensively for you. This is very similar to a drag and drop programming language, except of course it's very domain specific. So it's very specialized for DSL, Gfast, and wireless testing technologies, and it's not limited there. We're also able to expand this in the future to provide support for automating other technologies as well. So the basic idea of the test creator is you can create a brand new test on your own, either from a template that we provide you or completely from scratch. You can edit this test simply by dragging in certain elements that we call actions, which are kind of like programming statements. And you can then run these tests and view all the data via the reporting system. And there's a lot of things that this test creator does automatically when you're running a test, such as record any pertinent data from any device that you control. So as I mentioned, tests are built using actions, and these actions are created by us here at the IOL. So they're like specialized statements in a programming language. We have actions for setting DSLAM or DPU profiles, getting measurements from a DSLAM or DPU, configuring and running traffic and getting those results, and of course the basic control flow statements like if statements and loops that you would find in any other programming language. So actions in the test as they run will handle everything automatically in the background. So if I have a set DSLAM profile action, all you have to do is drag that into your test, specify which profile to set, and the action itself will handle setting that profile to the device and recording any useful information to the database for you completely automatically. This way, you can view that data as you wish later on using the reporting system. And all of these elements are reusable. So it's very, very modularized. So you have a common component that you can use for scripting multiple tests. So next up here, we have a quick demo video. This will showcase one of the CO tools that I talked about and then show you how easy it is to modify an existing custom test with this new test creator feature.
Welcome to Test Sentinel. When you first start the application, you'll be presented with this home screen that has a variety of different options and tools that you can choose from. We won't be discussing many of them in detail in this demo, as we will be focusing on the custom test creator in just a little bit. However, a very powerful tool of Test Sentinel is the CO device interface. This tool allows us to easily control any DPU or DSLAM that Test Sentinel supports in a very consistent and reproducible manner. For instance, I can connect to any of the DPUs I wish, select any port to control, and I can set or even create and load my very own profiles or select from any of the standard profiles that come with Test Sentinel, such as the 212A profile that is used for Gfast testing. These settings are all completely generic, meaning I can create a profile once, save it, and then I can set this profile onto any of my DPUs or DSLAMs respectively. This tool handles converting the profile to the appropriate commands based on which DPU or DSLAM you are connected to. Once I have a profile set on either my DPU or DSLAM, I can then check the admin status, set the admin status, and check the training status of my line, as well as pull any measurements that the DPU or DSLAM supports. This is a demo device, so I won't have very many measurements here. The same can be done for performance counters, or even getting a full graph of the bits and gains for a particular port on a DPU or DSLAM. Similar tools exist for controlling traffic generators or controlling noise and loop simulators. Test Sentinel still comes with the original test automation engine. This test automation engine allows for automation of TR-114, ID337 issue 1 and 2, and more tests. Now, while this test automation portion of Test Sentinel is somewhat customizable, meaning you can select which profiles to use, which devices to use, and what timing to use, it does not allow the user to fully customize or modify the test script. And this is where a brand new feature of Test Sentinel comes in, called the Custom Test Creator. For this demo, I'm going to create a very simple DSL reach versus rate test to show how easy it is to create and modify a test script. I'm going to go ahead and create a new test and give it a name, my demo reach rate. And when I'm creating a test, I can choose to create it based on a certain template that is provided by Test Sentinel. I'm going to base this test off of a simple reach versus rate template, which will provide us with the basic structure of a reach rate test that we can then modify and add on to meet our needs. I'm going to go ahead and save this test, which will then bring us to the test editor. The test editor works very similarly to a drag and drop programming language, except very specialized to a certain domain. The test editor might look like there's a lot to it, but each part is actually quite simple. Since I made this test based off of a template, you will see that this template comes pre-populated with some test actions, as well as comments on every single action. This way, a new user can get to know exactly what everything is doing when they create a new test, as this demo is just going to quickly gloss over some of the key features of making a test. The user guide and documentation also provides a lot more information on how to actually use and create a test. As I mentioned, tests are created using items called actions. An action is the smallest piece of a test and are what I'm clicking on right here. An action is kind of like a single statement in a programming language. You can see that here, I am connecting to a specific DSLAM. I am then connecting to my AWG, or noise simulator, and then connecting to a loop simulator that will simulate a certain loop length. There's a very wide variety of actions available, ranging from anywhere from simple if statements and loops, all the way to very specific actions such as controlling a traffic generator and getting traffic results, or getting measurements or performance counters from a DSLAM or a DPU. You'll notice that as I click on a specific action, the settings on the right-hand side change. These settings determine what an action requires to run. For instance, when connecting to an AWG or my noise simulator, I have to select which device to connect to. Note that this device isn't actually the noise simulator I will be controlling, but rather it indicates that when a user wishes to run this test, they must select a noise generator. I'll show you that in just a few moments. Tests have three major parts to them: events, sections, and functions. Events are denoted by a green E on the tab that is currently selected. You'll notice that I have the Check Setup tab selected, which shows me all actions within this event. The Check Setup event runs at the very beginning of every single test, and therefore I'm using it to connect to a DSLAM, noise simulator, and loop simulator. Similarly, there's an End test event here. This event runs at the very end of a test, or if there's an issue in a test and there's an error, this will also run. This helps us to clean up anything in our test, such as disconnecting from our devices. Next are sections. Those are marked with a red S on the tab. This template already comes with a basic reach rate section created, though of course you can make as many as you wish. A section can be chosen to be run or not to be run by the tester. So it's really useful to split your tests up into individual sections, that way you can choose what needs to be run and not be run. This section simply sets a few variables, including the DSLAM profile that we will be using, the loop lengths that we will be using, as well as the loop type. As you can see here, this test defaults to 26 AWG loop type, ranging from 0 to 5,000 feet in 1,000 foot increments. Finally, it defines a variable for noise, which is just set to -140 white noise for this demo. It then calls a function that is created by the template using these variables that will actually run the reach rate code. Functions are denoted by an orange F next to the tab. You'll notice that this section is calling the run basic reach rate function, which we will take a look at now. This function will begin with setting the appropriate DSLAM profile. In this case, it is accessing whatever parameter was passed to this function and setting that profile to the DSLAM. It then does the same for the noise simulator and sets the noise simulator profile, and then enters a for loop block that loops through every single loop length I wish to test in this reach versus rate script. All of the other actions are placed within what is called a point block. A point block is purely used for organizational purposes and makes the data that appears on the database easy to understand and be organized. So, as we iterate through this for loop and through every loop length, we set the WLS profile, or the loop simulator, to match the settings that we defined, and then we begin resetting, training, and stabilizing the ports of our DSLAM via the train lines action. Every action has a unique label associated with it. As you can see, this one is called Basic Trainer. They can be renamed to whatever the user wishes for easier test creation. This is very important because most test actions are able to produce what we call measurements, or essentially data that we can use later on in our test after an action runs. We can view the measurements of an action by clicking the View Measurements button when an action is selected. By doing this, we can see that our Train Lines action will provide us with some information regarding the training process, such as whether or not all of the lines trained, how long it took a certain port on the DSLAM to train up, or if there was a stability failure, for example. We can use this information later on in our test script. For example, the if-else block here, that comes after training the lines, checks to make sure that our basic trainer action had all of the ports on the DSLAM trained and it makes sure that there was not a stability failure. If the ports on the DSLAM did train and there was no stability failure, the if statement will run. In this case, we take line measurements which get automatically recorded to the database, just as all of the measurements of every action in the test, and then we print to the screen some useful information. This can be completely customized. In this example, we just print out the actual data rate and SNRM of the line. We can then do various things such as setting the point status to a pass or a failure. We can also add items called section metrics, which are requirements for a section to pass. In this case, we make sure that there was no connects. Basically, we ensure that the DSLAM port trained for each loop length. Now this test will run as is, but what if we wanted to make a quick modification and get performance counters and compare them for each loop length? Well, we know that in this if statement here, we take our line measurements if the line is trained. We can do the same thing with the get performance counters action here. We'll take the get performance counters and drag that into our test. Immediately, every single performance counter recorded from the DSLAM will be recorded to the database for us automatically, and we can also view its measurements. For instance, the get performance counters action will provide us with almost any performance counter that the DSLAM or DPU supports. And again, this information is automatically recorded to the database so that we can view it once the test runs. We can do other things such as getting the bits and gains by simply dragging in the bits and gains action if we so wished. I'm going to go ahead and save this modified test and we can go ahead and run it. Back on the home page, we can select the test engine and select the test that we wish to run. In this case, I'm going to load the demo reach rate file that we just created, which will open a variety of settings. Here it will list all of the sections available within the test, in this case only one, that we will select to be run. It will then show us a bunch of variables that are in our test that we are able to optionally change if we so wish. This way, if I wanted a shorter train time, reset time, and stability time, I can change those here without going into the test creator and changing the test script every time. For example, the next tab over has our DSLAM profile that we could change here, as well as the loop lengths that we are running our test with, all without re-editing the test. Once these settings are set, we can go to the Device Configuration tab. This will allow us to select the actual devices that the test will be run with. Once all of these settings are through, we can go to this Test Status tab, enter in our tester name, and begin the test. This test will begin by running all of the actions that were in the check setup block. So that was connecting to our DSLAM, noise simulator, and loop simulator. You'll notice that once those devices are connected, we will see a live log of all of the commands being sent to the DSLAM, noise simulator, and loop simulator. There's also a status log that prints out the current progress of the test. For instance, here we can see that we just started loop length 2,000 feet, it set the WLS profile, and it's now training the lines for us. Once the lines get trained, it takes line measurements as well as our performance counters. We can see that it printed out a nice table of all the performance counters, even though all we did was add a single get performance counters action to our test. We can also see the printouts of the actual data rate and SNR that we had in the log status action. On the left, we can see what current section is running, as well as what loop length is running down here as well. There's also an action viewer that can show us what current action is running in our test, and we are able to set breakpoints and view variables as the test is running, which is very useful for debugging and creating your own tests. Welcome to Test Sentinel.
Good. We're going to come back and talk about some use cases now. So these are some use cases that we think would be useful based on a couple of interested parties, ways you could leverage Test Sentinel in your own laboratory to do things for yourself. So our first use case is service provider labs. We know that some of the most common laboratories are within service providers themselves for deployment, and the common use case for them is to test incoming devices against a range of already supported CO equipment. So what you could do there is many service providers, of course, create their own testing. So that could be automated with our custom test tool. You could integrate this tool with all of the COs that you support and easily rerun the same set of testings on different devices that come in. So if you have a new vendor bringing in a product that you want to enter your network, you can ensure quality before allowing it to enter your network in a nice, consistent fashion. by running the same testing or whatever testing you please. Maybe you're testing a new feature as well, a new part of the technology. You're curious how that works. That's also achievable with this. This will let you also, because you're creating reports, easily compare devices and get performance differentials between them, so you can decide between products here as well. We already support a range of DSLAMs and GPUs. We're constantly adding more as we need to use them in labs. So chances are we will already support a lot of the CO equipment that you have, or we can help you add it. Another use case here is regression testing for equipment manufacturers and chipset manufacturers. Obviously, new firmware releases happen often. We all kind of know how the software development goes. Sometimes you create regressions, unfortunately. So it's important before releasing any of these versions to check for regressions. And when you have other parties requesting tests from you, you can easily rerun those tests, test your new features with this, try a range of different stuff to save on that process of manually configuring DSLAMs and trying features or wireless equipment, doesn't matter what it is. So you can make sure that you haven't created any regressions. You can generate proof that issues that you've seen before are resolved now, because you saw a passing test, now or a failing test, now here we have a passing one. And you can easily test for performance improvements as well. You can do performance testing and see, okay, this is my rate this time, we've changed some stuff, now we've gotten better rates. And you can easily generate proof of that, which is important. Another use case is just for general custom testing. So we can easily create non-standard tests. Obviously, there's a lot of customization here where you can create testing for new features that are non-standard, stuff that other parties may not be interested in as much as you. So say long reach VDSL or something like that. You could create a feature like that to create your own test case to try this in more of your deployment scenario. So that allows you to go above and beyond just what testing the standard body's generating and work on your own stuff. Or test things in a range of unusual scenarios. Maybe you have some odd field issue you need to proof out, and you can try to reproduce that scenario here. So leading into this, we'll talk about a couple user benefits. These are similar, but just some general benefits of why use this tool over traditional automation. I think every lab has had some experience with creating automation. Typically, many times it's done in-house or done through another tool, and I want to speak to why we think our approach is very good in this regard. We have a lot of time and effort put into device abstraction. So we are independent of which devices. We support a number of devices. Obviously, they all have different capabilities, and that can have some requirements. But in general, we support a classification of device, such as wireline simulator. So it might not matter the specific wireline simulator as long as it has similar capabilities and we support it. Or, for example, like Tony mentioned with DSLAMs, you can set a profile. It's done in a generic fashion in our software and can be set on a number of different DSLAMs and DPUs. You don't have to write a script that's for one device, which is important. Again, there's reusable parts. You can, create your own tests, retool what we have, or, retool your own tests later on to do different things. Create, copy paste, easy stuff like that to, I want to try this test with different settings. You can just do that very simply. One key point here was that it was easy to understand. Obviously, a lot of automation requires deep programmatic knowledge. We were trying to limit the amount of programmatic knowledge required to create these tests. That's why it's drag and drop and it's very easy to understand. It should be much more easy to follow than having to open up some Python code and try to figure out what's going on there. That might require software engineers, where editing a test and managing this might be much more in the realm of traditional engineers dealing with this stuff. So we try to limit the amount of deep programming knowledge. Of course, you need some to create tests, but it's definitely simplified. And I also get our expertise. I think in the lab as a whole, we have many other automations. We are somewhat expert at dealing with automation. In general, we have the knowledge to create, like I said, reliable, robust, and accurate testing automations that give you good results every time. And we're quick on our feet when it comes to creating new tests. So other benefits for having this tool is that you can test everything in-house, or you can easily compare between multiple labs. They can both have the same tool. So the same process and the same automation. One lab can create another automation, pass it to another one, and they can easily compare the results. So that makes it very simple to deal with that. Common tooling in all laboratories is very important. So you can, like I said prior, easily recreate field scenarios. So maybe you're running into one particular issue in the field. You can recreate that with the tool and create a test that makes sure that everything can pass that bar from then on just by rerunning that test. We also have lots of debugging tools, as Tony mentioned. There's stuff to easily configure DSLAMs, DPUs, recreate test scenarios just, for manual debugging. That's all driven out of our need, which is why we created those, our need to recreate test scenarios and debug things. So it's definitely useful for everyone else. You can easily create reports too from the tool, simple PDF reports that can show good, you can be passed around, shown, proof of that you have passed this test from a reliable source. And of course, you can save money on development. It's obviously very expensive and difficult to create testing automation. It can be a lot of effort. It can take a lot of time to maintain. Sometimes people leave, and then you have this code that somebody has to figure out how to deal with. You can definitely save on that issue, which is something everybody shares. So just a quick little review. Test Sentinel already automates a range of BBF test suites. This is through the older test engine. Is just out of the box, set up your devices and go, which is all those listed there. Custom reach versus rate testing is just an easier way to build a very simple reach versus rate with different profiles that can also be done in the new custom engine, as Tony demonstrated. And we have more test plans coming soon. We are always motivated to test them for our lab service, so we have to create them in the automation. So TR380 is coming soon, as well as some of our own Gfast performance test plans and probably more wireless stuff as well. All of these are ready to go. We already have built the presentation layers. Everything exists for these, so they're ready to go tomorrow if you need to do that. It can save on a lot of time because we're already motivated to do them. So that's the end of our presentation. We're going to jump over to Q&A now. If you have any questions, you can enter them in the box through Zoom, and we'll answer them now. So I have a question of how long it takes to add new equipment to Test Sentinel, and what is the process to do so. So it depends on the equipment. It can take a decent amount of time if it's something we haven't ever encountered, but if it's a device type we already know, such as a WLS or CO, like a DSLAM or DPU, it's usually a matter of a week. And usually we add the equipment. There is support for in-house development of drivers, so to speak. We have a mechanism in which you can create your own drivers and add them in and use them. It's a little bit complicated, so we try to do most of that in-house if we can help it. Usually we just ask for access to the equipment, and we can get it done pretty quick because we're very familiar with dealing with that kind of stuff. I see another question about do you need to be a member for the IOL to get the tool? No, you don't need to be a member of the IOL to get the tool. For support, we require that you come to us and are a member. Generally, we will support the tool support the software functionality of the tool if you're not a member. If you're looking for actual feedback on test results, we generally require membership for the tool. But you can definitely get it, run it, set it up in-house. We'll support you for that process. You don't have to be a member. I see a question here about support for TR105 and TR115. We plan on adding some support through the newer engine for those test plans. We definitely have the capability of doing some of those test cases. It's something we could help you get done in your lab if you need to. It depends on support with equipment, whether or not you can generate the range of settings. Those tests are somewhat complicated in terms of their requirements for noise and loops and stuff like that. So that's something we can definitely do. We do some in-house, we just haven't released it yet. So that's definitely something coming down the pipe there. See, does the IOL sell other tools as well? Yes, we sell other tools for protocol testing, like IOL Intact is a popular one. Yeah, there's several other automations that we sell, all available through similar means. If you need to test IP types technologies. That's where Intect comes in. Packet type testing is done through that tool traditionally. I see a question about how working with us to test DSL products. So there's also, if you're not aware, the IOL is a membership-based service where you can access our lab. You can send us your devices. We will perform all the testing for you, generally a membership basis. We do that for all these technologies that I've mentioned, GPON, Gfast, DSL, wireless, and then 31 others. So if you have any testing needs that you don't want to handle in-house, or you need a third-party report or opinion on, we can always help with that. You can just contact me, and I'll hook you up with the right people. So there's my contact information if you need me. As we said, for Test Sentinel, we have several test packages based off needs. We can always work with you to create features that you need. We're very flexible when it comes to that. We're always trying to improve the tool. So if you need something that I haven't mentioned, you can talk to me about it. I can help you, and we can talk about solutions for that. All the information can be found on our website about all of our services, including the tool itself, and where you can get it, where you can send quotes, testing services we offer, and news about what we're doing around here is all available on our website. All right, if there's any last minute questions, you can submit them now. Other than that, I think we are all set here. So I'd like to thank everybody for coming. If you have any other questions, you can feel free to email me at any time. We'll answer them. Yeah, thanks for coming, everybody.